In the lesson 5.5 example, uniform and random decimals, we'll review the concept of continuous random variables and their density curves. Suppose you use a calculator or a computer random number generator to produce a number y between 0 and 1. It could be any decimal like 0.84522 and so on. The random number generator will spread its output uniformly across the entire interval from 0 to 1 as we allow it to generate a long sequence of random numbers. Now the probability of distribution of y is the density curve of a uniform distribution, shown in purple here. Now in this section we learn that the probability distribution of a continuous random variable is described by its density curve. And that curve must have two characteristics. First, it must always be on or above the horizontal axis, and it must have an area of exactly 1 underneath it. So for part A, when we want to explain why the probability distribution of y is valid, we note that first of all, this density curve is entirely above the horizontal axis, and the area underneath this density curve is actually just the area of this square. 1 times 1 gives us an area of 1, so this is a valid probability distribution for this continuous random variable. Next, let's find and interpret the probability that y is between 0.3 and 0.7. To do so, we note that that would mean y would have to fall somewhere in this range. Maybe it's 0.4 or 0.57692, could be any value between 0.3 and 0.7. The probability is actually just the area of this density curve. Well, we know that this rectangle has a height of 1, so we just need to find the width, which in this case is from 0.3 to 0.7, or a width of 0.4. So that area is 0.4. For some additional practice with continuous random variables and their density curves, try exercise 1.